In this episode, we're going to take a guided tour of technical risk from a privacy perspective, but we'll do it in a way that stays beginner-friendly and avoids drowning in engineering details. When people hear technical risk, they often jump straight to hacking, but privacy risk is broader than that. It includes accidental exposure, misconfiguration, excessive access, weak monitoring, and data being copied into places no one remembers. The reason we look across infrastructure, cloud, endpoints, and storage layers is because personal data rarely lives in one neat box. It moves through networks, applications, backups, laptops, mobile devices, and cloud services, and the weakest link often determines the outcome. Privacy management does not need you to configure firewalls or tune encryption settings, but it does need you to understand where technical failures tend to occur and what kinds of controls reduce those failures. By the end, you should be able to describe common technical risk patterns and explain why layered controls matter for confidentiality, integrity, and appropriate use. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at CIPM in the Bare Metal Study Guide series. A useful way to begin is to define what we mean by layers. Infrastructure is the foundation: networks, servers, virtualization, and the basic services that make systems run. Cloud is a delivery model where infrastructure and platforms are provided by a service provider, often with shared responsibility for security. Endpoints are user devices like laptops, phones, and workstations that access data and services. Storage includes databases, file systems, object storage, backups, logs, and archives where data rests over time. These layers overlap, but separating them helps you spot risk because each layer has typical failure modes. For example, infrastructure risk often shows up as weak network segmentation or exposed administrative interfaces. Cloud risk often shows up as misconfigured access policies or public storage. Endpoint risk often shows up as lost devices, malware, or saved credentials. Storage risk often shows up as over-retention, unencrypted copies, or backups that quietly keep sensitive data long after it should be gone. Thinking in layers is not about being fancy. It is about building a mental map of where privacy can be compromised. Let's start with infrastructure because it shapes what is possible everywhere else. From a privacy standpoint, infrastructure risk includes any condition that allows unauthorized access or makes it hard to detect and contain problems. One major risk is flat networks, where many systems can talk to each other freely. If an attacker or malware gets into one place, it can move laterally and reach databases or file stores containing personal data. Another risk is weak identity control for administrators, because privileged accounts can override many protections. When administrative access is not limited, logged, and monitored, you lose confidence that only the right people can reach sensitive systems. Infrastructure also includes how systems are patched and updated, because known vulnerabilities are a common entry point. Again, you do not need to patch systems yourself to understand the risk. When patching is slow or inconsistent, the organization's privacy exposure increases because attackers can exploit public weaknesses. Infrastructure risk is often invisible until it's exploited, which is why governance and assurance matter. Cloud adds a special twist because control is shared between your organization and the cloud provider. In many cloud models, the provider secures the underlying hardware and certain core services, while your organization is responsible for how you configure and use them. Privacy incidents in cloud environments are often about misconfiguration rather than sophisticated attacks. A common example is storage that becomes publicly accessible because access rules were set too broadly or inherited from a template. Another example is overly permissive identity policies that allow too many users or services to access data. Cloud also makes it easy to create copies, snapshots, and replicas, which is great for reliability but dangerous for privacy if those copies are not governed. A dataset might be moved to a test environment for convenience or replicated to a different region for resilience, and suddenly the organization has created new access pathways and transfer constraints. The key privacy lesson is that cloud increases speed and flexibility, which increases the need for strong guardrails. Without guardrails, data sprawl becomes the default. Endpoints are where technical risk becomes personal, because endpoints are directly tied to human behavior and daily work. Privacy risk on endpoints includes loss or theft, malware that steals credentials, and ordinary mistakes like sending files to the wrong recipient. Endpoints also create risk through local storage, such as cached files, downloaded reports, and screenshots that contain personal data. Even if the main database is well protected, a downloaded spreadsheet on a laptop can expose thousands of records if the device is compromised. Another endpoint risk is weak session management, like leaving a device unlocked, reusing accounts, or saving passwords in unsafe places. Remote work amplifies these risks because devices leave controlled office environments and connect through varied networks. Privacy management does not need to enforce every endpoint setting, but it should understand that endpoints are a common leak point and that strong device management, encryption, and access controls are privacy controls. If you ignore endpoints, you are betting privacy on perfect user behavior, and that is not a reliable strategy. Storage is where privacy risk often hides the longest, because storage is where data persists. When people think about personal data, they often imagine the primary database, but storage layers include far more than that. File shares, document systems, collaboration tools, object stores, email archives, and backups can all contain personal data, sometimes in unstructured forms that are hard to track. A key storage risk is over-retention, where data remains accessible long after the business purpose ended. Over-retention increases breach impact and makes rights requests harder because you cannot delete what you cannot find or what is scattered across many systems. Another risk is unencrypted storage or encryption that is inconsistently applied, such as encryption in one database, but not in exported files or backups. Storage risk also includes weak access control, like shared folders open to large groups or permissions that accumulate over time. From a privacy perspective, storage is not just where data is kept. It is where your promises about minimization and retention are either honored or quietly broken. Now let's connect these layers by focusing on a few recurring risk patterns that show up across all of them. The first pattern is excessive privilege, where accounts or services have more access than they need. Excessive privilege makes incidents larger and harder to contain because a compromised account can reach more data than necessary. The second pattern is unclear ownership, where no team feels responsible for a system's privacy posture, so updates, access reviews, and retention management drift. The third pattern is poor visibility, meaning insufficient logging, weak monitoring, and unclear alerting, which makes it hard to know when data was accessed or moved. The fourth pattern is uncontrolled copying, where data is exported, replicated, or synced into new locations without governance. The fifth pattern is inconsistent safeguards, where encryption, access controls, and deletion practices differ between systems, creating weak spots that attackers or accidents exploit. These patterns matter because they help you evaluate risk without needing to know every technical detail of a system. You look for patterns that predict failure. A privacy-focused way to assess technical risk is to ask how the organization prevents, detects, and responds at each layer. Prevention includes access control, encryption, secure configuration, and segmentation that reduce the chance of unauthorized access. Detection includes logging, monitoring, and alerting that reveal unusual behavior, such as bulk exports, unusual login locations, or access outside normal hours. Response includes incident procedures, containment actions, and the ability to investigate what happened and what data was affected. You can apply this to infrastructure by asking how privileged access is controlled and monitored. You can apply it to cloud by asking how configuration is governed and how drift is detected. You can apply it to endpoints by asking how devices are managed, encrypted, and monitored for compromise. You can apply it to storage by asking how permissions are reviewed, how encryption is applied, and how retention and deletion are enforced. This approach keeps you from focusing only on prevention and forgetting that detection and response are what limit harm when prevention fails. It is also important to understand the idea of shared responsibility, not just in cloud, but across teams inside an organization. Privacy risk is rarely owned by one team. Security may own certain controls, IT may own device management, Engineering may own application design, and operations may own processes that generate exports. Privacy management coordinates expectations and ensures that responsibilities line up with the organization's obligations. When responsibilities are unclear, controls decay. A system might be launched with good access controls, but over time new teams are added, permissions widen, and no one notices. Logs might exist, but no one reviews them. Backups might be created, but deletion policies might not cover them. So part of assessing technical risk is assessing governance. Who is accountable for decisions that affect data access, retention, and security? This is not bureaucracy for its own sake. It is how you keep controls from becoming temporary. Another beginner-friendly concept that helps you assess risk is the idea of data pathways. Personal data travels through pathways, such as from a web form to an application server to a database to analytics to backups. Each step creates potential exposure, and each step might have different controls. If you do not understand the pathway, you may miss where data is copied or transformed. For example, logs might capture full request contents, including personal data, which then gets stored in a centralized logging platform accessible to many engineers. Analytics tools might collect identifiers that can be linked back to individuals. Support systems might store ticket attachments that include screenshots of personal data. These are not always malicious choices. They are often default behaviors of systems and teams. Privacy management should ask where data flows and whether each hop is necessary, minimized, and protected. When you can describe pathways, you can spot where controls need to be tightened. Technical risk assessment also needs to consider that the impact of a failure depends on the sensitivity and scale of the data. A minor configuration mistake in a system that holds only limited contact information may be serious but manageable. The same mistake in a system holding financial information, health details, or data about children can be far more harmful. Scale matters because it changes the stakes. One exposed record is a problem, but thousands or millions can become a crisis. This is why privacy programs often classify systems by the types of data they handle and the number of records involved. Even without detailed engineering knowledge, you can ask the right questions. What kinds of personal data are stored? How many individuals are affected? How widely is access granted? And what is the worst realistic exposure if something goes wrong? Those questions help you prioritize which systems need the strongest controls and the most frequent review. To wrap up, assessing technical risks across infrastructure, cloud, endpoints, and storage layers is about building a clear picture of where personal data can be exposed and how controls behave under real conditions. Infrastructure risk sets the baseline. Cloud risk often comes from misconfiguration and data sprawl. Endpoint risk ties directly to human work habits and device security, and storage risk is where retention, access, and encryption can quietly fail over time. The most useful approach is to look for recurring patterns like excessive privilege, poor visibility, uncontrolled copying, inconsistent safeguards, and unclear ownership. Then you ask how prevention, detection, and response work at each layer, and whether governance keeps those controls reliable. When you can explain these ideas in plain language, you can collaborate effectively with technical teams while still staying focused on privacy outcomes. Privacy management succeeds when data stays protected not only in the database, but everywhere it travels and everywhere it rests. And thinking in layers is how you make that protection realistic.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.